Limits going to infinity of quotients, meaning these are fractions. So now we're starting to dive deeper into what happens as we get infinitely large in one direction or another, and for a dynamic of fractions. All right. So the key here is where is the biggest, what are we looking for here? The biggest what? The biggest exponent. P-O-N-E-N on X. On X, or our input, or whatever it might be, wherever we're going to. So that is what takes over on these problems, is as we go to infinity, everything else drops out and doesn't play a part anymore. And then we just have to kind of be careful about negatives and positives. So careful about your negatives and positives here. So we'll do our best and see how it goes. So as we go to infinity here, what is going to grow faster? Well, what's going to grow faster is this part right here, this negative 5 x to the fourth. And then it's helpful to kind of think about what's happening on the bottom with negatives and positives. So we got an x cubed on the bottom. So basically, this is kind of what's taking over. And we're looking at negative signs and stuff too, just to be careful and considering even and odd exponents. So as we go to positive infinity, what's going to take over? Well, the top is going to get bigger and bigger and bigger. So this is always going to be positive on top. This is always going to be positive on the bottom because we're positive infinity. And then this negative sign is going to flip it into negative infinity. So I would say this is going towards negative infinity, okay? Because the biggest exponent is on top. There's a negative 5 next to it. So that would lend itself to negative infinity. So in this case, it's unbounded. All right, let's see if they talk about what I was talking about. Okay, so let's just examine their solution. If the degree of the numerator is less than the degree of the denominator, then the limit is 0. So let's just talk about these since we're here. So this is if you have if the top is less than the bottom. Basically, this is what's happening here. So as this gets infinitely big, as this goes towards infinity, basically you have a fraction that's getting smaller and smaller. Think about like if a bottom number gets bigger, 1/2, 1/4, 1/8, 1/16, it's a smaller and smaller piece. As that goes smaller and smaller, all of this goes to where? 0. All right, if the numerator is equal to the denominator, then the limit is the ratio of the leading coefficients. So this is if you have like 5x squared over 2x squared as your biggest exponents. So they reduce out and it would turn into 5/2. That's what this one does as we go to infinity for the x's. And then if the degree of the numerator is greater than the degree of the denominator, the limit is unbounded. And that's what we had here. We just have to be careful with the negatives. I always like to kind of consider that. That's more of an advanced concept, but it's nice to let you know. Limit is unbounded. Yes, yes. So they're kind of reducing things out. That's how they show it. And yes, that -5 just plays a part in it, but everything kind of goes into that like unbounded asymptote. Okay. See if the next one's any different. I'll try not to take so long on it. All right, so do you remember what we're doing here? We're looking at the biggest exponents on x. So I just kind of like looking at the ones that are in charge here. So the one in charge on the top is a -2x squared. The one in charge on the bottom is a 4x cubed. So what happens as we go to infinity, the bottom is going to take over and it's going to get closer and closer to what? 0 when the bottom takes over. All right. And for so far, we're going to positive infinity. Let's see if I haven't seen any negative infinities yet. but we'll deal with those. That's where you have to be careful about your sign changes and exponents and stuff. This one right here, the one on top in charge is a 3x cubed. The one on bottom in charge is an x cubed. So as these go to infinity, these take over and they basically cancel out. You're left with 3 over 1. Answer is 3. Okay, any of these negative infinities, positive again. So this goes to unbounded. This one goes to 0. I'm not seeing any negative infinities. This one goes to negative 1/4. I'm just going through what we had just talked about. And this one is unbounded, biggest exponent on top. All right.